Thank you, John. Welcome, everybody. I'm pleased to be speaking to you today. I'm working with a net. I'm here to introduce you to FishLamp. It's a relatively new work group of the Great Lakes Fishery Commission's Sea Lamprey Control Board, and it is charged with looking at the connection, trying to understand the connection between sea lamprey and lake trout. I'm employed by the U.S. Geological Survey. I also have 50% of my time contracted out to the Great Lakes Fishery Commission, and I'm currently a PhD student of Mike Jones at Michigan State University. You can take your picture now, Mike. So why FishLamp? Lake trout and sea lamprey are both high priorities for Great Lakes ecosystems for different reasons. The Great Lakes Fishery Commission and its partners track these animals, but sometimes when you follow their trends over time, they don't line up. And it leaves managers in an awkward position of not really knowing whether things are improving or declining or what's going on. So FishLamp was formed to try and address this disconnect, to enable managers and decision makers to make better informed decisions. So why lake trout? Lake trout rehabilitation is a priority in the Great Lakes. It's a species that's believed to be self-sustainable in all the lakes. It's an important component of the deep water food chain, and it has well-established evolutionary relationships with other native species in the lakes. Why sea lamprey? Sea lamprey control is also an important priority for the Great Lakes. When invasive when invasive sea lamprey are kept at control levels, it reduces predation on other desirable species. So it enables us to meet fish community objectives, and sea lamprey control is an important part of a healthy Great Lakes ecosystem. So we, Great Lakes Fishery Commission, its partners, we have an index of lake trout abundance. Every year, tribes, federal agencies, the province, and the states all go out and conduct gillnet surveys in the Great Lakes. They record the number of lake trout that are captured. They record the effort that it took to capture them. And it gives us an index of lake trout abundance over time. And here I'm just showing you the index for Lake Ontario and Lake Erie. While they're capturing these lake trout and have them in hand, they're also examining them for marks, scars, wounds from sea lamprey attacks. That information is also recorded, so we also have an index of the number of marks per 100 lake trout that are observed on these fish. We also have an index for sea lamprey abundance over time. So every spring, sea lamprey control agents from the Fish and Wildlife Service on the US side and Fisheries and Oceans Canada set traps in streams to capture sea lampreys, adult sea lampreys that are on their spawning migration upstream. This trapping is conducted on just a small subset of the streams, but there are ones that have historically produced high numbers of sea lampreys in the traps. And you saw an example of where those streams were, I think, in Chris's previous talk on Lake Erie. And so after we've got the trap catch from these traps, we've also got indices of abundance for each of the Great Lakes. So again, we've got these metrics. We've got lake trout abundance over time, we've got marking rates over time, we've got sea lamprey abundance over time, but they don't always line up. So a recent example of this is on Lake Erie. After we saw these numbers in 2014, in the 2015 wounding year, the abundance of sea lamprey dropped and the abundance of lake trout increased, both good news items for Lake Erie. Now, my expectation would be, as a result, I would have thought that the marking rate would decline. I mean, if there's fewer sea lamprey out in the lake and more lake trout out in the lake, you would just think that the marking rate would go down, but we saw just the opposite. The marking rate increased. So imagine you're a decision maker trying to decide, you know, how to tweak sea lamprey control on Lake Erie. How do you know whether this is good news or bad news? Which metric do you believe the most? It really puts you in an awkward position. So that was the impetus behind the formation of the FishLamp work group. We're charged with making this connection between sea lamprey and lake trout. And the charge comes directly from the Great Lakes Fishery Commission vision. Provide a model that relates sea lamprey abundance to lake trout abundance and wounding rates in each of the Great Lakes. So the work group was formed in 2016, and we have several fisheries experts, including Corey Goldsworthy, Ted Tresca, Jeremy Hold'em, Jim Markham, and Mike Hansen. And sea lamprey experts, Mike Siefkes, Mike Steves, Jessica Barber, and quantitative experts, Travis Brendan and me. Now, before I get into telling you a little bit more about what sea lamprey is doing, I want you to, yes, I'm giving you permission to open your laptops and grab your cell phones and go to the website that these two gentlemen are holding up and enter the magic code in there. And Haley will, while you guys are focused on that, will be switching over. Yes, this is wonderful. So I'm going to give you a minute to catch up. Haley was worried she was going to be slower than you, but I can see that's not going to be a problem. So it looks like some of you are there already. When you get to the site, there's a question there that asks you, how often do you think about lake trout? How often do you think about sea lamprey? And as the answers roll in, they should be showing up here. And I probably should have said what my prediction was before I asked the question. I figured that there would be a small minority of people that thought about sea lamprey every waking moment. Those would be the sea lamprey control agents. And then I wasn't really sure how the lake trout would pan out for this group. All right, good. I'm going to close that off. Now there's another question. Haley can advance me to the next question. Yep. Now this one speaks directly to those abundance metrics that I was talking about. Which one do you have, what level of confidence do you have in each of those metrics? How confident are you in the lake trout time series? How confident are you in the wounding rate time series? How confident are you in the sea lamprey time series? This one, I have no idea how this one's going to play out. I didn't dare to predict. It looks like lake trout's winning. All right, interesting, okay. So from this, I'm taking that looks like wounding rates are actually in third. It's a close behind sea lamprey, but for that example I gave you on Lake Erie, maybe most of you in the room would not have been daunted by the wounding rate. You would have said, look, I believe the lake trout numbers, I believe the sea lamprey numbers, I think this is good for Lake Erie. Okay, thanks, Haley. Can send me back to my presentation world. That was awesome, thank you. Okay, so back to the work group. So let me remind, we are charged with developing this model of sea lamprey and lake trout and the wounding rates. But what we're going to find when we're trying to develop this model depends on what we're looking for. So we need to think carefully about what we're looking for. We have met a few times already, and we've talked about a number of different things that might influence the connections between lake trout, sea lamprey, and the marking rate. I'm just going to focus on 3 for this talk. So the first one I'm going to talk about is host switching. And I think there's a pretty good analogy to this if you haven't heard of host switching before. It's called beer switching. So if you picture yourself coming to a lake committee meeting, let's say in Canada, and your favorite beer is Labatt Blue, I don't think you're going to have a lot of trouble when you go to the bar afterwards finding the beer that you are looking for, right? Finding your preferred beer. But next year, if the lake committee meetings are in the US, you might be in a bit of an awkward position where you're forced to change away from your preferred beverage to a substandard brew. So sea lampreys might be caught in a similar position, right? If lake trout are available, lake trout are their preferred host in the Great Lakes. They're going to seek them out far and above what their abundance is there. But what if lake trout are not quite as available as they used to be? What are the sea lamprey going to do? Are they going to switch to a different host? If they switch to a different host, if they kind of drop their preference and go with what's in front of them, what we're going to see as assessors is a drop in lake trout wounding rates. Even though sea lamprey numbers are high, even if lake trout abundance is low, we're going to see a drop in the wounding rates that doesn't quite make sense to us. So this is one possible explanation. Now, this might not be something that's particularly easy to see in nature, but we think we have the chance to observe it in Lake Ontario. If there's a place to see it, we think Lake Ontario is the place to see it. So in Lake Ontario, sea lamprey abundance has been relatively constant over time, but the lake trout abundance has been shifting, as have the wounding rates. So you can hear, in this case, the alternative host is Chinook salmon. We're also looking at measurement error. So what I mean by this is simply that if we are not very precise in our estimates of these trends over time, it might simply be that in and of itself, that noise around those estimates that's contributing to a signal that doesn't seem to make sense. So a pretty easy way to address this would be just through a simulation. How high do we have to turn up the noise on these metrics to make the signal show up some strange results? We're going to look into that as well. And then my third example has to do with wound lethality. So what if, under different conditions, lake trout are more or less likely to survive an attack from a sea lamprey? So one of the tricky things about studying wounding rates on fish is that the only fish that we see are the wounded fish that survived the attack, or at least they've survived so far. What we don't see is the fish that succumb to their attacks, right, that have already died or are unavailable for us to sample. Now, when they're collecting information on the marking rates, they're actually recording additional information about those wounds, how serious the wounds were, and how much they've healed. So one idea that we've got from the FishLamp work group is, can we look at the essentially the distribution or the number of these different types of wounds, and might that tell us a story about the wounds that we didn't see, that we never saw? That one's a bit more of a puzzle. I'm not sure if it'll work out. So just to wrap up, lake trout rehabilitation in the Great Lakes is a priority. Sea lamprey control in the Great Lakes is a priority. That's why we're collecting information on these and tracking these abundances over time, as well as the wounding rates over time, but sometimes the trends don't line up. So the FishLamp work group was formed. Our goal is to make sure that these trends do line up or make sense, have an explanation behind them. This will enable decision makers to assess the progress of these species, have informed decisions about what's going on. And in the end, perhaps the model will also provide a tool to improve our targeting of sea lamprey control in the Great Lakes. That's all I've got.